In my last video, I demonstrated a bridge I'd built between B&R's automation runtime and the ROS ecosystem. Keeping with this same bridge building theme, I'm now going to demonstrate in this video the use of a Jenkins continuous integration pipeline with an Automation Studio project. So first, a quick word about continuous integration, also known as CI, and why it's important. In software development, this is the process of regularly building and testing a codebase as new additions are made. So you can see here in this graphic the general life cycle of a software project, starting with the planning stage, then the code stage where the software is actually developed, the build stage where the source code is converted into executable format. This build stage is separated from the release and deploy portions by continuous testing. And what I want to focus on today is the combination of the build and continuous testing stages in order to ensure high quality software. I'm applying these two stages to an Automation Studio project as an example. So let's take a closer look at my setup before we jump in. I have three main environments that are interacting here for the CI tests that I'll be carrying out today. The first on the bottom right is the local development environment. This is really just supposed to be a developer's generic workstation. It has all the tools the developer would be using to create the code on a daily basis. So for instance, in my case, Automation Studio. This is where the development is occurring for the project. Git Kraken, this is my local Git client that I'm using for version control. Google Chrome is used to pull up the UI for manual testing and verifying that the UI actually looks the way it's supposed to. And Katalon Studio, as we'll see in a few minutes, is the tool for automating the web testing portion of things. So that's kind of the local development environment. The next hop from that local development environment are a set of cloud services that we're going to use to bridge the gap between the local development environment and the build server that's doing all the heavy lifting. The main cloud service we're using here is GitHub, which is just the remote host for my Git repository. And we'll also make use of the SMTP server that Gmail provides in order to send email notifications. We'll get into that a little bit later. Finally, then, we've got a build server. This in CI is where all of the heavy lifting occurs every time an operation happens on the repository. And a standard typical operation would be making some changes to the code base, pushing those changes to GitHub, and then being notified on the build server of those changes, which is going to trigger a whole host of operations along the build and testing front. So here we have Jenkins, which is an open source tool that's used to automate continuous integration processes. So it can do stages back to back, such as building the project, initiating the execution of certain binaries, and then applying some test scenarios and reporting back on the results of those tests. All of these things are possible for Jenkins. Next, on the build server, we're going to have some local tools that are being used to build the project. Now, these are tools that are installed automatically with Automation Studio in the background, such as the br.as.build.exe or the RUC package creator, or even RUC itself. Next, we have Google Chrome in headless form, which is going to be used to run the tests that we've created on the dev environment, and Katalon Studio working hand in hand with Google Chrome. The setup I'm using for my demo features both the build server and the local dev environment running on my PC, but this is just for the sake of simplicity. In reality, in a production environment, they would almost always be distinct, and the build server is in fact often even encapsulated inside of a Docker container for flexibility. Let's now take a look at my Automation Studio project as a starting point. As you can see, it's a fairly small project, just a handful of tasks here and a simple map view HMI with a single page. I'll pull that page up and show you what it looks like as a starting point for our tests. We have a conveyor that's moving 3 cases of different colors and shapes forward, and the cases are being spawned at regular intervals. The conveyor is subject to a series of move parameters that describe its motion profile, and in the middle of the screen we have output status information on the system. Finally, on the right, we have commands that we can issue. And this is fairly representative of all HMIs, where you have inputs that can be received from the operator and outputs that can be watched. Now suppose that this conveyor logic is part of a much larger code base that's constantly evolving, And as the developer of the logic, I want to set up a few automated web tests to ensure my logic isn't broken by future changes. There are many tools in existence today in order to automate web testing, and the one I've selected for this demo is called Katalon Studio. This is a tool that can be used to record user interactions with an application via a web browser. The recordings are automatically converted into script form and can then be edited or replayed at will. Before I start getting into these recordings though, I need to set up a baseline. Remember, we're going to be recording my interactions with an executable ARSim that's running in the background, so I want to make sure that we're in a known starting state before beginning the recordings. I'll close the web browser and I will issue a warm start to Automation Studio to get to that point. Next, we'll take a look at this project. I've created a simple Katalon Studio project called Conveyor Testing, and projects feature a series of test cases that will be evaluated one after the other whenever they're invoked. First test case we're going to create here is called Case Move Test, and my objective with this test is to verify whether or not the blue case has moved a sufficiently large distance whenever I click the Start Auto Mode button and let it run for a certain period of time. I could go ahead and start entering in steps manually to my script, but by far the more efficient way of doing it as a starting point is to use the web recording tool. This web recorder prompts me to enter in a URL, and I'm specifying the Matthew URL here, and I can then specify my browser of choice that will then be spun up by Katalon Studio as a type of slave browser to Katalon Studio. You can see here at the top the banner indicates that Chrome is being controlled by automated test software, which is Katalon Studio. As I interact with the UI here then, new steps will be populated in this list on the right, and Katalon Studio is basically building up a history of what I've done with the web UI. So the first thing I'll do is click on Start Auto Mode and watch the blue case appear and move forward a given distance. I'm going to let it go nearly to the end, and then I'll click on Start Auto Mode again to stop it. And you can see we have both of these clicks recorded to the right in our script. So now we have a record of the commands. The last thing I want to do is click on the field that I want to evaluate as a verification, a part of my testing that we would call an assertion. So I will click on this, and my testing within this web recorder framework is now done. I can stop it. It appends this last step to close the browser. And when I hit OK, Katalon Studio prompts me to create new objects, one for each of the HTML elements I interacted with. So the Start Stop button and the position output. OK, and now our script is available for editing. We need to go in and add in some timing constraints here because the recorder that Katalon Studio uses does not automatically impose time on it. You can see that there really aren't any delays introduced here. It just would try to go through these steps as fast as it could. In order to prevent it from faulting out when it does that, I'm going to add a few waits at the start of the script. Wait for page load as a fairly generic one, and then a second wait that targets our particular button called Wait for Element Visible. This is going to pause the script at step 4 until this particular element becomes visible on the HTML page. After that, I'm happy to go ahead and click this button, and I want to introduce a delay after this so that effectively the system runs its auto mode logic for a period of 5 seconds before I do any more interactions with it. So a delay of 5 seconds is inserted here. We then are going to click the same button again to stop auto mode, and I'm going to add one more delay, this time shorter. 2 seconds will be sufficient in order to ramp all the way back down to a 0 speed. Delay of 2 seconds. After step 8 completes, we expect that the conveyor will no longer be moving. Now we move on to the feedback portion of this test where we're trying to see whether or not it succeeded. And this is where the additional text field that I clicked on comes into play. We don't want to click on this field though, and so really clicking on it was just a shorthand maneuver in order to get this object in our catalog. Now I can easily change the item that I'm going to be using It's called item, but it's really just a function. I'll move it to get attribute. And I want to get a specific attribute of this HTML element. The attribute is called input. Or sorry, it's actually called value. I've figured out that it's called value based on inspecting the HTML content that Matthew creates. Once I get that attribute, I want to store it in a variable, and then I want to run an assert statement on that variable to see whether or not it has the desired value. We'll click on variable here, and the logic is to reference the variable, which is in string format, convert it to a float, and then verify that it's greater than 3.0, which is 3 meters. We're almost done here. One last change needs to be made, however, to our objects. And this is again something I discovered through experimentation with the actual HTML elements. Map view, you can see, has some names from the actual editor that get added in to the HTML elements. This is a widget that's called numeric output 3 coming from the content animation page. But that's not the only thing that figures into the name. We also have a series of divs, and lastly we have to type in this input element to be able to get the numeric value. So I'm going to save this, and at this point we can go ahead and save our test case. We are ready to run it. Now remember, the test case that we recorded actually moved things around with ARSim. So before we run this, we want to do another warm start to make sure that things are in good shape. And we will initiate the run by clicking on this button up here. Katalon Studio is launching a few background drivers and getting ready. And it will also display the web browser in the foreground so we can see what's going on in real time. Here it is. You can see that it started the move, and down here it shows you what step it's in. We finished the move, and the test has completed. Now we can take a look at what happened actually in this log, and it's very interesting to see the results of our steps. All of these individual steps succeeded as far as Katalon Studio is concerned, and at the end here we have our step where we're getting the attribute. If we click on it, we can see the attribute was equal to a value of 3.8, and that was greater than our value of 3.0, therefore indicating that basically we had successfully completed the test. The next step here will be to create one more test in order to demonstrate what it looks like to run multiple tests. We'll call this speed check test, and we'll proceed as we did with the other, with one exception. I'm not going to warm start ARSim between the two tests, because at runtime they will not be warm started either. They'll be running back to back. So we run it from the endpoint of the prior test. You can see my blue box is still in position here. Before I start a move, this time I want to change the set speed. So I will click on this field, set it to 2, and hit enter. You can see my steps being recorded here. Then I will start auto mode, and while it ramps up to speed, I will identify where I need to actually click, which is this actual speed button. Once I get this value, I'm going to be stopping and ending my recording session. I've got everything I need. We're prompted to create our new items. We do so. Then I open this up, and I'm going to add in the same few weight elements as we did last time, although we will be waiting for a different element to appear in this case because it's the first one that we're clicking on. Wait for element visible. Once that element is visible, we go ahead and click on it, edit the two values, so pressing number 2, then pressing enter. Then we click on the start button, and we want to introduce a delay after that. So our delay here is going to be simply giving it enough time to get up to speed. 3 seconds is sufficient in this case. Once it's up to speed, then we want to perform our assert statement, but before we can do an assert, we have to get the value to perform the assert on. So we'll do another get attribute here, this time pointing to that speed field. Once again, the value is value, and we'll save it this time to var b. introducing next our assert statement, we are going to wind up with similar logic to what we had before. So variable b to float is equal to 2.0. We want it to be exactly equal in this case. And after we've done that assert, we are content to stop the conveyor and close the browser. So the last step before we can actually run this is to come back and make sure that the value we're trying to read is properly formatted here. So this is the div inbox class box input. I'll edit this value over here. Once again, adding in the input element at the end, and that will take care of it. So I am good to go with the running of this second test. Speed check test is ready. We'll make sure that we don't have the element pulled up and begin the test. Browser pulled up. You can see our element is now at 2.0, and if we look down here, var b was in fact equal to 2.0 whenever we had reached speed. So that concludes the two tests that we wanted to set up. I can close these out, and the last step we have to do in Katalon Studio is create something called a test suite. This test suite is important because that's the only thing that we're going to be pointing to from the Jenkins side. Jenkins is only going to know about a single test suite that it's going to attempt to execute, and that test suite will contain all of our individual tests. We're going to call this conveyor test suite, and you can simply drag and drop your test cases into it. Save this, and I'm going to close Katalon Studio at this point. My next step is going to be moving into the automated side of things, and we will basically be representing the build server side. So I want to close out of Automation Studio as well, as we won't be running that on that side. We've now completed the local dev environment portion of our CI test, namely the setting up of the tests using AS, Chrome, and Katalon Studio. The next stage is going to take us now to the build server, where we take a closer look at Jenkins. Jenkins is an open source tool for continuous integration. It can automate a series of steps to build, test, and deliver software products, and is extremely versatile. It has a huge number of plugins that support integration with other software platforms and has a lot of versatility built in. The interface with Jenkins works through a web browser, and on the landing page here you can see that it shows me a list of projects I'm working on. In my case, I only have the one named First Pipeline, which is essentially a single software entity that I'm trying to build and test and maybe perform some other operations on. Jenkins reports at the highest level what the status is of this particular pipeline project, and you can see if I hover over this, it says failed. This is because the last time I used Jenkins, my whole process did not complete successfully, and as a result, our weather report is poor. You can see that 4 out of the last 5 builds failed, and 1 out of 2 tests is currently failing. This is, again, historical before I set up this demo, obviously. What we're going to do here is drill down into this first pipeline and see what it looks like. So we're on the main status page, and this shows high-level information about the pipeline. In the top right corner, you can see the test result trend view, which shows you for the 2 tests that I've pre-configured beforehand and just configured once more for you live. We were getting success on both at times, failure on one, and success on the other at other times, depending on which build I executed it on. In the bottom left corner, you have the build history. This shows every single build that was initiated through Jenkins of this project, and I've done 143 of them. Several of them have succeeded, but most have failed. Any number of reasons can cause it to fail. It doesn't just have to be a compile error during the build. It's either a compile error, obviously, during the build, or perhaps an assert statement that failed during the test, or something else altogether. You can see, by the way, Jenkins is refreshing regularly here. The midsection is perhaps the most informative. It shows you a detailed view of the different stages involved in each of the most recent builds. So I've got a checkout from the source control, which takes about 1 second for each of these. Then the build, which takes on average a minute and a half, perhaps a little bit more, followed by an install portion, a run portion, testing, and then a few post actions. This kind of makes up the main view that we can look at when we're looking at the particular pipeline. Next, what I want to show you is how this pipeline gets configured. It's pretty neat. You can actually do it through the repository. So if I look at all the files that we have in our repo, the root level of the repo has a file called Jenkins file, and this is the way that Jenkins configures itself whenever it checks out a new repository. It's called a declarative pipeline file, which uses the syntax that you can see here. The highest level is just a series of stages that you can impose upon Jenkins, each of which contains its own series of steps. If we look closely at the first stage, the first step is calling a batch file that's located at this path and passing in an argument of building. The second step is again a batch command to invoke a Python script, which is going to do all the build for us. And the same applies here with my setup for the install and run. I'm either calling Python scripts or batch files as slaves. And then at the end, I have another batch file, which is intended to run the Katalon Studio script. You'll notice too up top that there's an agent specification. This is very handy if you want to multitask or move things around. Natively right now I just have it set to any, which means it'll use the local machine. But you can set that, for instance, to a Docker image and point it to a specific spot where you want it to execute and parallelize your efforts if you want to. So it's a very powerful tool. And the way it works is that Jenkins pulls this file from the source control system whenever it checks it out during a build, and then it configures itself based on the steps that are listed in this file. There are also a plethora of other commands available in addition to bat or junit. I've only used a very small sample of what's actually available here. So going back to Jenkins, I'm going to now initiate a new build manually and take a look at how it works. So you can just click on Build Now. And Jenkins, as you can see, started another build down here. Now I can look at it from the high level, which is very, very helpful, but I can also drill down into this build itself, and specifically interesting, I can look at the console output. What I want to point out here is that at the beginning, it's doing a checkout from this remote URL. So it's getting the GitHub URL from my repo, which is with this one right here, and pulling remotely. So that's what we were talking about earlier with this cloud service. Jenkins is pulling from GitHub. Next, you can see that it's building. So it printed out a little build string that I configured. And for those familiar with Automation Studio, this will look like familiar territory, obviously, because it's just an AS build being redirected to the Jenkins console output. This will take a few minutes, obviously, because we triggered a rebuild in Automation Studio. And I'm sorry, not Automation Studio. We triggered a rebuild in the background using the br.as.build.exe tool. And we pointed it to the desired configuration, passed in all the important parameters, and it's working on building everything here. So it has to go through map view, it has to go through my task, and it's going to go through some OPC UA at the end here with a few final links that will get created. This corresponds to the build stage right here with my Python script that's executing. Map view adds in a lot of extra files that have to be moved around when you're building, and so it takes it a moment. Once the build completes, the next thing I'm going to be doing is generating a runtime utility center package, which can then be used to start an ARSIM instance locally. So those steps are all encoded in Python scripts or batch files in the background, and we're creating that package right now. We have no errors, which is good. The install portion is starting up the local instance of ARSIM. And interestingly enough, when you start ARSIM from Jenkins, it does so in a headless manner so that you can only interact with it in the background. You don't actually see the console icon. but it's running because we can see it through map view. So the installation is still carrying out right now. We see we have no error and the program executed successfully. The run is successful as well, which means ARSim is up and running. And now we've moved into this testing stage, which is calling our test.bat. Test.bat is referencing the Katalon executable in headless mode. So it's going to run our specific test suite, which we called conveyor test suite earlier. And if we scroll down, you can see it's actually going through our steps right here in real time. Introducing the 5-second delay, then a 2-second delay, and then it finishes. And now moving on to test number 2, the 3-second delay, followed by the close of the browser, and we are done. Recording of the test results completed, and you can see that the entire process is done as far as Jenkins is concerned. Let's go up to the top and see what we can glean from this at a higher level view. If I go to this test results section under my build number 144, we'll find that we have 2 test cases here, the case move test and the speed check test, and both of them passed. So no issues to report. If I go back to the first pipeline, my build shows up as blue, which means it succeeded. You can see over here, both of them are blue for this number 144, and all stages are green here. No problems to report in this instance. Let's recap briefly on what happened here from a high level. I opened up the Jenkins interface through the web browser and commanded it to initiate a build manually. The first thing it did then was a checkout of the latest commit on the master branch from GitHub. It pulled all the contents down and then initiated a build of that source code using local tools present on the build server, vr.as.build.exe, etc. After the build completed, Jenkins then initiated a batch file that started up ARSim, and finally sent a command locally to Katalon Studio, again on the build server, to start running through its full test suite, which in our case encompassed 2 test cases that both completed successfully. So that was kind of the full A to Z sequence of a good build and test scenario that we saw reported as successfully on the Jenkins main landing page. The next step then, and last step really in our demonstration here, is looking forward a few weeks in our development cycle, going back to the real world scenario, when a number of changes perhaps have been made to the code base and we still have these test cases that can be run regularly against the code. So in order to simulate this, I'm going to go into Git Kraken and open up one of my files from Automation Studio, add in a small amount of logic that I know at this point is dangerous, and then we will go through the same process of building and see how it affects things. So the small change I'll make is to hard code the velocity to 1.0. And our comment will be hard coding this because it was necessary for me. Supposing here that I'm a different developer coming in, making a slight change to the code base, unaware perhaps of the original test suite that was set up. This, as we can tell right now, is going to break one of our test cases because it will prevent the velocity from being set to 2, therefore no longer meeting the required assertion. Now that I'm done with this, I can save it, and I will go ahead and commit my change. Stage all files, small velocity logic tweak. So we're committing our changes and we will push to the repo, the remote. We're now synchronized with the remote. Small velocity logic tweak is up to date remotely. Once that's done now, we are going to go back to Jenkins, and all I'm going to do is just initiate another build. Build now, and we can see it's going to start off. I'm going to pull up the console output, and I'll show you that we are in fact operating off of the latest code that I just pushed to GitHub. That's the comment that I had in there. And we're just going to go through the exact same steps once again, and we should see at the end a different result. That's what we expect. Now while it's building, we are free to navigate around. We don't have to stay on that status page. It'll keep going in the background regardless of where we are. And I want to comment briefly on a few different mechanisms we have of triggering this build. I'm using something very simple right now, which is just the manual mechanism of clicking that button. But in a production environment, you would obviously not want to do this. There are several provisions for how to initiate this. One of them would be for perhaps on a time basis, where you can tell Jenkins to pull the repository every so often and see if any changes have been made. But another one which could be more useful perhaps is to set up a type of webhook between Jenkins and the repo so that as soon as a new commit is made on that master branch, it triggers the build in Jenkins. That would probably make sense in a practical way so that we ensure all of these tests are run against every new build on the master branch. Another feature that we'll mention here, actually you can tell that our build is progressing nicely, and we'll see in a few seconds how it compares to the other ones. Another feature while we're waiting for this build to complete is the plugin capabilities that Jenkins offers. Now we have to come back up to the root level of Jenkins in order to get to this, but once you do so, we can go to Manage Jenkins and Manage Plugins. And really all I want to show you is that there's a huge plethora of plugins that are available for Jenkins to interact with other environments or to add on to its functionality, simply put. I have the list shown here currently installed, and if you look, actually that's not true, these are the ones that are installed, and if you look at available, you'll see the scroll bar gets very small indeed. There's a lot of plugins that can be used with Jenkins. This is because it's an open source tool that has a lot of popularity, a lot of traction in the industry. So many different platforms have made the effort of developing plugins that can speak with Jenkins. Just a quick list that I've come up with here of things that are quite useful is the following. We've got some dashboard plugins which allow you to customize the way that the reports are shown in Jenkins. We've got some monitoring and metrics plugins for detailed real-time status reporting on jobs. There are performance publisher plugins for storing the results in a variety of different formats. I'll show you actually after this next test completes what it looks like to view the results in an HTML format sent as an attachment via email. There are many scaling tools available for allowing Jenkins to interact with Docker containers, Kubernetes, deploying things on AWS, ECS, or Azure AKS. And the list goes on. There are pipeline tools that allow you to customize the way that Jenkins file looks and make use of new commands. And the last one in my list, source control management tools that allow you to talk to a wide range of source control systems. So the bottom line here is that Jenkins can be expanded substantially and is probably flexible enough to fit most use cases. Alright, we can see now back on our page that we're done with our install, run, and build, and we got to the test step, but the test failed. So let's dive in and see what happened here. If we look at this root level of the 145 node build, you can already see the test result shows one failure, and it would tell us what it is right here. So we can click on this, and as we would expect, the test assertion where we're verifying that the speed is equal to 2.0 now failed because we forced the speed in code to 1.0. So it was impossible for this to work. Although the inclusion of this information natively inside of Jenkins is really great and useful, especially given that you can navigate to it quickly via Jenkins' built-in hyperlinks, it's not necessarily in the right format for communicating these results to outside parties. And that's why Jenkins also comes equipped with the capability to export the data in many different ways. Among others, it's able to tie in with Slack or Asana to publish data, or, as I'll show you here, send an email with the test results attached. Let's go back briefly to our build and look at the console output. You can see at the very end here, there's a line indicating that an email report was sent to this address. This email report just contains the results of the Katalon Studio tests that we carried out at the end. And we'll pull those up right now as a last step and show you what we're looking at. In the body of the email, you see the high-level results of the tests, and if you download the attachment, you can take a closer look at the details. They're in HTML format here. We can expand out this test suite, the only one that we were executing, and we see, most importantly here, that one test passed and another failed. Color coding helps to guide you to which one you want to look at. I'll take a look at the first one here and zero in on this step where I know we were getting the value. I can confirm the value was 3.8, which matches or is greater than what we were looking for. So it satisfies our condition and we understand why this passed. Let's look next at the test case that failed. We get a nice summary at the top of why it failed. One of the assertions actually failed to complete successfully, and we understand this has to do with the fact that our code was changed. So again, the use case here is that somebody who wasn't aware of the old requirements within the code base modified something and triggered this problem. This would then be brought to their attention pretty quickly during the next build and would be easy to catch before deployment. If we scroll down to the bottom here, we can see that the value is in fact 1.0, which was lower than what we needed it to be. So you can see in conclusion that Jenkins is a very powerful tool for handling the continuous build and testing portion of a project, and I think a lot of our Automation Studio projects could stand to benefit from this type of approach, preventing unexpected consequences in the field. That's it for this demo. Thanks for watching this far, and please feel free to reach out if you have any questions or comments.